All right. Okay, let me bring back this chat window so I can see the questions. Oh, streaming that, Jimmy. Yeah. So, yeah, definitely good ideas. You guys can help to get some audience. Maybe try it next time. All right. Not sure if there's anything interesting to share, but later on when we get more about the design stuff, it will be very, very helpful. Okay, so let's give a shot.
Professor, that you're gonna release the slides too for these slides, because there is nothing on the course content so far.
Oh yeah, so I will upload slides as well. So I'll put that the slides will should be go to the Blackboard.
Yes, so it's gonna be released after.
Day one, the slides are mostly because, about the introductions, so really not much technical things. But from today, this one will go to Blackboard.
Oh, perfect. Thank you.
All right. Okay. Well, it's good to know everyone's pretty serious about the topic. So I won't let you down. And as I mentioned last week, if you remember, I probably can change the way you write your Java code, okay, at the end of the semester. So your code, hopefully, after this course, after a couple of assignments, it will be different from the ones you're writing right now. I'm pretty sure the one you're writing right now is not really the ideal object-oriented approach, okay? So I will do my best, and I have done this course many times. I think there are quite a lot of practical things you can learn right away, okay? You don't need too much time to practice. Some of the idea, if you get it, you can see it, start to try it, and you'll be able to improve yourself right away. All right, so today I want to talk about the differences between object programming and the traditional way of programming. Now, when I talk about this procedural programming language, I guess some of you probably never even heard about it. All right, so that is the type of a language before this object-oriented programming languages. Now, some of you might know, okay, we're talking about the C programming language, for example. Some of you might have heard about Fortran. Yes, those are called procedural programming languages. But exactly why do we classify it that way, and what are the differences? And so that's the goal for today. I want you to see the difference between the two types of language so that you know why the newer type of language, which is object-oriented, is better. Okay, so let me actually move forward. So this is actually a statistic I got recently. This is for 2020, and it's not really much changes compared with the past years. Obviously, Python is growing, still kind of taking a lot of popularity, and Java still there for sure. And then other languages, C++, C#, and JavaScript definitely getting popular. So, but again, the point of this picture is to try to show you that most of the language today we use are object-oriented, right? So, but then the question really is, when you are using Python or Java, how many object-oriented features are you actually using? That's actually a very, very big question. And I bet that a lot of you are actually, for example, especially when you're writing in Python, guys, most time when you write in Python, you are actually using that as kind of a scripting language. You're just following the old style procedural programming language way. I'll explain what that looks like. All right, so I don't know, for example, a quick question, how many of you are actually using Python classes? All right, you probably do that for every single Java program because you have to do that. It's required for every single code. You need to have a class, but Python, since class is not required, I guess most of the time you're basically just writing some functions and some kind of scripts. But that's not really called object-oriented programming. All right, so so that's why, since pretty much all the language today are object-oriented, so you really need to be a master of an object-oriented programming developer. So your code should look like professional code. All right. So yes, I think it's a popularity. You know, there are different kind of measurements today. Some people use GitHub repositories, some people just do some surveys. You know, I'm not trying to say that this is a very official or how accurate it is, but pretty much it shows definitely see the popularity. I mean, between Python and Java, okay, one thing my idea is that it's impossible for one to replace the other. Okay, even though Python is more popular, I don't think Python can quickly replace Java or C++ because it's a different type of language, right? So it's interpreter based, and it's fast, it's easy, it's concise. But Java has been changing itself as well. Some of the new features also try to make Java, the language itself, simpler and easier to write. And also Java is really stable. And another thing you shouldn't ignore is Java has been used in the industry for such a long time, and nobody can simply drop Java and then get everything done in different language. Not to mention Python is not really good for some things like enterprise level web services. Python is definitely not stable compared with Java. But Python, the reason it's so popular because it's easy to learn, it's fast. Also, a lot of this AI data science stuff is done in Python. That's why it's so popular. So I think eventually it depends on which direction you want to go. But knowing and being good at Java definitely is a very good foundation, because a lot of features you can see that in Java, but not too much from other languages, especially when we talk about object-oriented design. Okay, all right. Yes, legacy code. Yeah, so you need to actually need to maintain those. All right, let me see another question. What makes it object-oriented is a user interface with buttons? Not really, Christian. So you're talking about the UI stuff. That's why we want to focus on this topic from this course. Okay, when we talk about object-oriented, it's more about the design idea, the style of your code. It's not about what you're making. Even when you are making user interface, for example, in old days, guys, when you are making Windows, for example, in the early days, I don't know what's the first version of Windows you're using. Anyone use, for example, maybe you guys know Windows XP, right? So that's around 2003. Earlier than that, you got Windows 2000, you got Windows 98, Windows 95. And then the first version I use is something called Windows 3.1. Okay, that was really, really early. But that Windows 3.1 was written in C only. At that time, I don't think they even use C++. So C is a procedural language, so you can still use that one to make UI. So back to your question, Christian, the OOP is a design idea and principles. It's not specific about what kind of software you're making. So let's take a look. So this is kind of a brief history that shows you the kind of a major language. Obviously, languages are more than this, but some of these ones, the machine code, okay, zeros and ones, that's when the computer was created, right? So this is the only thing you can do with the binary. Obviously, very difficult to code, and then people create this language called assembly language that you can, I'm sure a lot of you have done this one in some of the other courses, move, add, those kind of simple commands, but you're operating directly on the registers and memories. So again, too hard to use. So C programming language came out, and then that suddenly become a dominant language because it's so powerful. It's a high level enough for you to write things very quickly. You can do so many different things for your system, for a computer. And that's still being used today for a lot of the lower level implementations. And also later on, people create things like Fortran. Fortran is just one typical language that's in a very high level that's specifically designed for scientific computing. So a lot of functions. To some extent, it's similar to Python today. For example, the reason people use Python to do a lot of AI and data science is because Python has so many good libraries such as SciPy, right, NumPy, scikit-learn. They have all this function that already been done to do a lot of this complicated mathematical computation. Fortran is something similar. Compared with C, Fortran is much easier to use to do this calculation. So it's easier to use, it gains more popularity. But all of these languages fall into this category called procedural programming language. I'm going to talk more about what that is. But then since then, people created C++. That actually is a big change. C++ was not the earliest object-oriented programming language. I think the very first one was something called Ada. Okay, I never used that one before. I only learned that from the textbook. But that Ada was the initial idea about object-oriented programming language. But the C++ making it more popular because C was popular and then C++ was built on top of C. So that's actually reasonable. And then Java improved so many things over C++ because C++ shows a lot of shortcomings, limitations, very hard to use, very error prone. So Java tried to fix every single problem came out from C++. That's why Java was at a good point that very quickly Java become a very dominant language. Okay, so we'll talk more about the difference between C++ and Java, and also I know a lot of you will have a lot of ideas and opinions about which one is better. Okay, I can guarantee, as I mentioned at the end of the class last week, anytime when you bring this question, C++ or Java, which one is better, you will have fight. Okay, you will have an ended fight that people will support different sides, and then nobody's gonna change their opinion. Okay, so I'm pretty sure you also have some ideas, but you have to admit that Java came later. So Java tried to fix a lot of issues you see from C++. So that's why it's easier to use, it's safer, it's a little bit more efficient in terms of development. Okay, so that's kind of where we're at right now. The Ruby, I mean, this one, I don't know why they put it here, but maybe because the image is a little bit old. So I'm not sure how many of you use Ruby. I don't think the Ruby is a good language or easy language to use. I had a very little experience with it. But the reason they put Ruby here is because Ruby is specifically used for the web services. And then the most famous framework called Ruby on Rails. And I don't know any team decided to do a Ruby project, but in the past year, every year we can see one project at least that use Ruby on Rails. Definitely very powerful in building web applications. The reason they put Ruby here is because Ruby is more high level than Java that makes the web service development much easier. Okay, but these languages, okay, including Python or Go or some other language you see you'd be using today, they are all object-oriented programming language. Of course, JavaScript, that's another important one. Okay, the reason they're object-oriented programming languages is because they support these important object-oriented programming language features. Okay, so that's my goal for today. I want you to understand when we talk about OOP or procedural, what are these? How can you call a language as procedural? How can you call a language as object-oriented? Right. So to help you to understand why I want to talk about this one, I think you really need to know and understand some of the histories, especially the histories when the things are not very convenient. That way you will appreciate more about what you have today. All right. So I think the reason I use this example because this was in 2014. There was a World Cup in Brazil at that time. So I was just picking on one example from the summer that the soccer game, right? You got this green card, yellow card system. Not sure how many of you are soccer fans, but I do watch a lot of soccer. I care about soccer, but I don't have time to watch soccer anymore. However, yeah, no green. And then you have a green card as warning and yellow card as a warning, and then red card, pretty much you're out, right? So very easy to understand. It's such a standard system. I'm pretty sure there are some other games also use the same card system, but this one didn't came into 70s or 80s. Okay, so but the soccer game came really early in the early 90s, not 90s, 19 like 30s or 40s something, right? So one time I remember I looked at this documentary talking about this judging the referee history, and they talk about the card system. So this is how the soccer game were going on in the early days, I think in the 40s to 50s. You see, this is how the referees look like. They actually wear suits and ties in the soccer field. And then they didn't have the card system. But then of course you have rules, and they will give warnings, but everything that will be done verbally. Okay, you just tell the player, okay, you're take it easy. Okay, be careful. Next time I'm gonna let you out, or something like that. So you see the disadvantage of doing this one totally based on verbal is that the audience don't know what's going on, right? First of all, and secondly, there will be arguments. Then the judge said something, then people just don't agree, and then they fight, and then later on they don't, accept what you mentioned earlier. A lot of those issues happening, right? So some of the games got into the big troubles after the game is done. People were still arguing about something's happening earlier during the game, right? So in the 70s, this judge, Ken Austin, kind of came up with this idea based on the traffic light idea. And then they just said, why don't we just use this color, clear card system to tell people, both the players and also the audience, what's going on. Okay, so that's how this system was built. But from here you can see when we have this card system today, it's so convenient. But sometimes we don't realize how convenient it is until you see how people were doing this one in old days, right? So that's what the purpose here. We want to talk about procedural programming language, right? It's a big benefit you have today with all those OP, but that's why if you don't really take advantage of it, you're not really living in a modern programming time. All right. So let's come back to the topic. So what exactly is procedural programming language? All right. So it's a very simple concept here. I try to highlight two important items. Number one, since we call it procedural programming languages, procedural programs contains a lot of procedures. Okay, procedure is a term we don't use very often, but pretty much it just means functions or methods in Java. All right, so functions probably is the easiest way to understand it. You got an input and output, you got a function name, you can call this one. It's a really important programming element in any kind of programming languages. You can't really do anything without a function. All right, so same thing here in the past, we got something similar called procedures. All right. Another thing important about procedural programming language is that once you have the procedures in your program, then when you program it, you should actually follow this kind of a sequential idea to build your program. You basically need to use all those procedures to specify how do you accomplish certain tasks step by step. And obviously, every step could be a procedure. All right. So these are the distinguished features about procedural programming languages. For now, you can just think about when we talk about procedural programming languages, it's basically a bunch of procedures or a bunch of functions. Every function has input and output. All right. And now for those of you who have programming in C, I want you to think about and how the program looks like. That's pretty much what you code. You just code a lot of functions one after another, different input type, different return types, different names. You might have different multiple files, but every file we open it, they're all just functions. And when you start to use all the functions, you're just calling those one after another. All right. So C, Pascal, Basic, Fortran, they all follow the same kind of a style. All right. How many of you have programming in C? Type in the chat. Okay. Really good. If you've done some of the, yeah, I know some of you are doing the computer engineering. Yeah, very good, a little bit, right? So now we don't really teach C very often, but when I was in college, okay, it was back in 2003, okay, C should be the first language you learn for most of the time. But now we'd rather teach that one. A lot of schools start with Java, like in like ours. Some schools maybe teach you C++, but still object oriented. And even now the trend is people start Python right away. All right. So so things are changing. We'll talk more about why people are moving to that direction. But like earlier than my college life, people were mostly learning Pascal. Okay, this one you rarely heard about it. So there was also a software development platform called, yeah, Turbo Pascal, that's right. And also there was a software called Delphi. It built a desktop application that also uses the Pascal. Yeah, I used Pascal. I even used Basic when I learned programming back in 1996, I think, or 1995. I actually started learning Basic. It's also a pretty cool language. And then when I go to the middle school, high school, I did some of the algorithms. Believe it or not, I actually did some of the leap code type of question when I was in middle school. And then that time, a lot of competition were using the Pascal. And then when I went to college, I used C. So I had a kind of a good memories about this one. However, I'm not going to go back to this one. It's just too difficult. I can't even remember, how those syntax, everything works, all the pointers. It's too difficult. All right. Yeah, no, very good. Yeah, you also learned Pascal. That's very impressive. Okay. All right. So let's take a look at some more specific ideas behind the procedural programming language. All right. So some of these things keep in mind. Okay, when we are talking about procedural programming language, or just like the question Christian asked earlier, it's more about, it's not about the language features. It's more about design ideas behind it. Okay, so like procedural programming language also has a really important design idea, which is called top-down design. Okay, this design is really easy to understand. In fact, that's actually the design probably you will use at the first place naturally when you're trying to write a program to solve something. All this one does is to see what is the function you're trying to implement, and then how can I break down this big function into smaller functions, and then if you need to break it down further, then again, just keep going until you get to the point that this is a task that's manageable, and then you solve that one. So that's called top-down design. Okay, if you look at some of the figures here, okay, you start with the high-level goal, 3 steps, and then this step needs 3 more sub-steps, and then this guy here needs more functions. And then once you finish the design, now the code will be easy. So all you need to do is write for each individual function here, write a function or procedure. Eventually you connect them together. All right. So this is called top-down design. All right. Now, even though this is a kind of old-fashioned way to design it, but this is a really very natural way, a very straightforward way for us to design things, because that's how we solve complicated problems. Okay, as I mentioned, anytime you got a goal, right? If you look at a lot of these videos, or people sharing, I don't know if you look at some of these TikTok videos, and people are, I one time said something like, if you want to make $1 million and something like that, right? And it sounds a lot, but if you break it down, that means every day you need to make certain amount of money. That means if you have a product you want to sell for example, $50, and how many you need to sell. So when you break it down to the daily work, it doesn't sound that challenging. Okay, so that's kind of the idea behind the top down. And then what you need to do is actually to focus on the specific little task, and then get a function done. Eventually put everything together to get the big goal done. All right. There was also like this guy in China. He's like a guru in real estate, very rich guy. One time people were, I don't know if you saw some of this kind of videos, interviews. There was a reporter did an interview with him, and he said, okay, could you share some of the like lessons, experience to the young entrepreneurs? And then he said something like, oh, no, it's easy. You should have a clear goal and then break it down. For example, if you want to make $10 billion, okay, then I can start with just making $1 billion. And then you finish that one, then you will know how to do the $10 billion. And then when he said that, he put it in such a simple way that it makes you feel that this whole $1 billion thing is such a piece of a cake. Anyway, that was like a very hilarious interview. But the idea is the same. Okay, break down until you get to something that's easy to manage. All right, so here's the example. Okay, so this is a language written in Pascal. Okay, you don't have to learn Pascal, but one thing to keep in mind about Pascal is this language is considered to be the most clean, nice structured language ever. Okay, so the language was created, as you can see, to particularly fit this procedural programming style. Okay, they even use the keyword procedure, and not many languages are actually using this one. They also have a function. I remember I had a hard time to understand the difference between function and procedure. Eventually, I think they're pretty much the same thing. Okay, they just try to create this few keyword to fit to that kind of a language, design idea. So this one try to do this program to swap two variables, right? You swap two variables, and then really easy to read. Okay, you got a program, and then you put a name here. There's a procedure and swap, and two variables, they're integer type, and then you define another integer temporary, and then you do this kind of swap, pretty classical algorithm. One interesting thing about the Pascal is their assignment is colon equals. That's one important thing you should know about Pascal. This is probably the only language to do this kind of assignment operator. Okay, colon equals. All right, and then after that, you got a main function, pretty easy to understand. And then you got two variables here, and you got a begin and end. That's pretty much your bracket, right? So that's where the function ends. So you write, that's a print. You read, that's your input. Print, input, print, and then you call swap. Eventually you print the result. And then you got another part, the begin end, that is your main function. Okay, so now when you read this program, you will see this is the entrance of your code. You call this a main procedure. The main procedure go to here, and then they call this write procedure to write this off the information on your screen. They call this read input procedure to get your input from keyboard, another print, another input, another print, and then they call this swap procedure. So they go to this swap procedure here to do all the stuff. Once that is done, come back to call this write procedure to print stuff. Right? So that's how the procedure program works. Now, when you look at this one, you can see this is the highest level of the function or procedure, and then this is where they break down into steps. And the swap is another step they break further, and they write another procedure to do it. All right, so really easy to understand. So that's why this way is very easy for us to follow, because it's kind of how we attack certain difficult problem with different, the levels of complexity. All right, but you can see this language was particularly created for such kind of design. All right, now I have some kind of little, I don't think this falls into the coding interview questions. Okay, so, but I want to test you guys. Variable swap. Okay, right here, guys. Pretty easy, right? So you got a temporary variable, and then that's how you can swap the value for two variables. Can anyone tell me how can you do the swap without using the third temporary variable? Oh, really? Well, Jimmy, no, Jimmy, that one doesn't count. Okay, so I don't know how that. I don't know if that works in Python. Okay, that's cool, but that approach doesn't count. Okay, um, numbers. Okay, you can assume these are the integers. You know, bit operator, fine. Are you able to write it? Using only two. Okay, so I can have a test here. I'm gonna create a Python. You can do Python. Anyone can give a try to write it? I got a variable A and variable B. Okay. So if I have a temporary variable, things become easy. Right? However, if you don't use this T, what are you gonna do? Anyone can type something. You know what? I'm gonna send you this link here. Okay, you can just jump here to type it for me. If you got some idea, so I'm gonna put it here. All right. Oh, actually, I saw some of the solutions. Yeah. Give it a try. So why I saw you actually put there. Can you try this A and B thing here? Not using the third temporary variable. Okay. So anyone can type something here. Yeah, so V, I think that approach works. Okay, you want to type something really quick here to prove it? All right, go ahead, type it. It's just 3 lines of code. Again, I don't think this one could become an interview question, but you never know. Okay, so maybe some interviewer just maybe try to test you this one. Okay, it could be. But when I was in middle school, high school, I remember some of the CS teachers were kind of trying to like challenge us with this one. Yeah, Christian, I didn't know that feature. Okay, that's a good one in Python. So Python is a little bit special. There's so many things we can do in such a simple way. But how you get this implemented in the background, right? So I guess they probably still use the third variable. Okay, yeah, take a look at the code it did here. Okay, so it's a pretty good solution. All right, so when you run it, as you can see, the 2 variables got swapped. It's a very smart way. Okay, but however, this one only works with integers. Okay, if it's string, I don't think a string might be, but you need a different thing. But this is a very smart way to do it without the third variable. You basically get a sum and then use a sum to do 2 subtractions that you can get it. Okay, so anyway, guys, take a look at this one here. And
Why
then,
so fast?
oh, I'm sorry. All right. So that was just a little question here. It kind of reminds me. Okay, so let me come back to here. Okay, so that's the first idea, top-down design. Okay, so here's how Pascal is doing that. And then another thing, keep in mind that when you're using a procedural programming language is every time you write a procedure, okay, so you really need to think about input and output. All right, so this is the kind of a traditional way when we program. We believe that any kind of program is has algorithm, has data. So your algorithm is trying to process the data and to get some kind of output based on the input. When you're dealing with input and output, you need to know the data structure. And that's why data structure and algorithm is such an important course. It's still important today, but in the past, we only care about the input and output and then the process, which is the algorithm. That's why when you're writing the code, such like Pascal, you got a very clear definition on the function, the algorithm, as well as the input, of course, output. This one it doesn't use output, but if when there is the output, you also need to specify that very, very explicitly. Okay, input, output, algorithm. So that's the thing we're thinking every time when you're writing some kind of this procedural programming language code. All right. Today we're still doing that, but that's not the only thing we have in the design. We're thinking a lot more things. All right, so I'll show you more examples. Okay, so that's kind of what a procedural programming language is. Okay, let me summarize. You need to have a top-down design with a lot of procedures, and then you need to focus on the data structure and algorithm. Always think about input and output. How can you produce the output from input? All right. So quick example here, just to simulate how this thing works. Okay. Again, we're not be able to build a real mobile app to do this messaging system, where you can send and get input and also to receive then display. So I'm just trying to simulate a very quick like a code skeleton, mostly for you to see what the language looks like by following the procedural programming language design. All right, as I mentioned, that this one, you need to follow the top-down design and focus on the procedure plus the input and output. So I would just try to use, for example, a C programming language. Again, this is only to show you the idea, okay? I can't really think about some of the syntax. To be honest, I can't remember some of this syntax anymore, okay? And also the pointer stuff, how to do the string stuff, I can't remember those. But I just wanted to see the idea about using the procedural programming language. I'm just using the C as an example. Again, I used to be a good C coder, but now, again, totally forgot everything. And I don't have motivation to pick it up. It's really kind of waste of time, all right? So, but to show you the kind of inconvenient side of programming in this way, let's think about this problem here. We're talking about a messaging service, right? And then there are two functions. One is to send a message, and also you got to receive messages. Okay, that's the two high-level stuff. And then if you follow the top-down design, when you try to send a message, you need to think about, for example, how do I get the message from the input, all right? And then also you need to think about how do you, for example, send it through the network. And for the second function, I'll just summarize it. I'll try to simulate the top-down design. Okay, the big procedure, and then you will need to have one is how do you get the message through the network. And then maybe you need to display the message. All right. So that's the function I want to do. I did a top-down design. And then what I need to do is basically implement every single procedure one by one and then connect them, right? So I need to get a function or procedure to get a message from input, right? So I'll do something called like a get message, right? I need to think about input and output. So I need to get, for example, a string for my message. I guess that's how you can save string in C. You have a pointer of characters or arrays. Again, I can't guarantee this is fully correct, but something I can remember. Okay, and then you can do some of the keyboard input just like Java. Yeah. Again, there are get this one. There is a scan F thing. Again, I really can't remember some of those. I try to think about this really hard before the class. I Google some pages. It's too much, so I would just write some kind of a dummy code here as a placeholder. Okay, just assume that this is trying to do some kind of input, right? Something like that. Scan that, and then you will need to save the message. All right, so you will probably get a message somewhere. Assume you got this one saved. Okay, again, this code is wrong. Okay, it doesn't really do this thing, but I just want to show you the idea. And then, but importantly is you need to return this back. Okay, so this is how I follow the input and output style. There's the data, I use a string, and then I return that as output. This one doesn't need an input, so this is good to go. All right, so once I got a message, I need to then figure out how do I send this one through network. Okay, so I probably need a return type for this one. I need to tell you the status. So I will say something called send message. And then this one do need a input. All right, so I will do message. You're sending me a message, and I will send it off. Okay, so again, so this one, just to say that it's this one, send it off. The message has been sent out. And then return kind of 0 as a success. Otherwise, if something is wrong, I'm going to return something else. All right. Again, this is not complete, but just to see the idea. I'm just building all these procedures one by one. And for the receive part, okay, I need to get this message from network. So I will do a void, so just receive message. All right, so assume that I'm getting the data from the 4G network. All right, but I need to save the message, right? So I will save that somewhere in maybe a buffer. And think about this, your phone, you need to have a specific memory to save all the data, right? So I need to define some kind of a buffer. Same as the message type, okay, just the strings, all right? And then I will just say that, okay, the buffer will be equal to something, okay? So not sure how to write it. And then you're done, you got this message. And finally, you need another one to display the message, to show it somewhere. All right, again, it uses the buffer, okay? Probably uses the buffer character here. All right, so now we got this 1, 2, 3, 4, 4 procedures. Okay, the reason I do this for because I already did the top-down design, and when I start to use this one, it will be easy. All right, so I create a message. I will say that I want to get input, get message. Once I get it, I will just send it. All right. Or I have another thread. Okay, I don't know how to do thread in C. That constantly like looking for the network. If something goes here, and then I will you know, just receive message. All right. Something maybe you need to do a while loop, right? So you can think about that, a while loop. Just constantly receiving things. Once you receive that, and then we're gonna display the message. When you display, and you can just display the buffer, or maybe I will need to send it here. Okay, maybe something like this. All right. Okay, so a very quick way to just simulate this system, but I just want you to kind of see the way we code in procedural programming language. It's not about the language, it's about the design approach. Okay, top down, break down, smaller unit, smaller functions, and then just write it. And finally, you connect all this input and output that you get it done. All right. So as some of you actually mentioned, okay, Sandra mentioned looks very organized. I totally agree. I mean, I'm not saying this is a totally wrong design approach because that one has been used for so many years. Okay, that's how people program in. I bet, guys. So I like Jimmy's comment. This one should be the way you write code right now. Okay, I think when you're writing in Python, that's pretty much what you're doing. Okay, so that's why we want you to teach this, learn this course. Okay, that's going to change how you write your code. But anyway, back to here. This one has been used by programmer even today. Okay, so many years. So if you follow this one right, it can help you to get things done, especially get the complicated things done, and the functions, the data structures. Pretty much that's everything about computer science. Again, nothing wrong with it. However, there are limitations at certain scenarios. Okay, so that's why I want to summarize some of the problems with this one here. All right, so let me go back to the slides. And so some of the issues. All right, so the first one is this kind of a design, I mean, programming design approach or programming approach is too limited in terms of being expressive, being able to express for more kind of a concept. The really idea here is that because everything you have here are just procedural functions. And another concept you have is input and output data. That's it. That's all you have from the language. That means no matter what kind of program software system you're trying to build, everything you have is procedures. Okay, you want to build a game, it's a bunch of procedures. You want to make, for example, a content system. It's also about the procedures. You want to make like an embedded software system, procedures, data, all of this. Okay, so for programmers, maybe it's fun. Okay, but you can see there's clearly a gap between what the real world is trying to do and what the program is trying to focus. And you know, I won't say the gap will always be an issue, but the bigger the gap is, the more likely your code is not going to work in the way it's supposed to be. Also, for the ones who were in this morning 4D class, we talk about the software, right? Eventually, you build something, but that's not exactly what the customer wants. Part of the reason also becomes a gap because customer wants to use something with the real world concept, but we are just dealing with a lot of things at this lower level. It's all about programming. So because of this, you will see that it shows some limitation when you try to build complicated systems. If you're trying to do this kind of text message system, it's not really a big deal. It looks pretty organized, I totally agree. But when it goes to more complex scenarios, when your system got so many different roles and functions and some of the logic, different workflows, you will start to see some of these limitations. All right, so that's problem number one. The bigger problem is really about extensibility. That's really the thing you want to focus on this course. Every time we talk about design, okay, so you need to think about what do we mean by better design? The better design is all about extensibility, changeability. Now remember the figure I showed you on day one, this kind of a crazy electricity wire, right? I told you that I think the wire might work, but really the real problem comes when you try to fix something there. It's become a disaster. All right, so here the same thing. It's a little bit hard to change this kind of system, especially you think about this one, you follow the top-down design. When you're following this one, eventually you're piping all these procedures one after another. In many cases, one input produce output and that output becomes the next input. So they are kind of a chain and they depend on each other. Again, from the logical point of view, it's very easy to think about that way. That's how we do the thing step by step. It's just like a pipeline or assembly line. You make this one, you move on to the next stage. However, when you have that kind of a tightly connected step in pipeline, any part got changed is going to affect the other parts very likely. That's the thing we don't want to see. We don't want you to see that you want to make some changes, but it affects a lot of other areas in the code. Okay, so back to this example, guys. All right. One part that's very likely to get changed. Okay, back to this sending message example. Right now, I'm just assuming my messages are all based on strings. That's why I use this character. That might work in the early days when we have a very old type of cell phones. You only can send text messages. Today, you already send text message. You're sending all images. You're sending videos. All right, you send rich content. Okay, now I want to support sending an image, right? So now this program becomes more bigger problem because when you send an image, you can't really do, for example, a string, right? So I need to use a file, okay, in Python, or sorry, in C. I think that's how you do a file. Again, it's a pointer. It's everything about pointer. Okay, image file, and then you got to open the file and then read that file as a stream and then send it out or something like that. So now here's the problem. Okay, so you want to actually support this new type of message, and then suddenly all of this one doesn't work. Okay, because you got to change this one from character to file, and then you got to change this one from character to file. You got to change this one to file, and the buffer had to be changed to file as well. And then this one here, file, and this one here, file. All right. So as you can see, this is a very simple line of code. Okay, I only have 30 lines of code. But if you want to support this new type of message, you almost touch every single function. All right, depending on how you write these functions. And that's actually very expected because we're following the top-down design. The top-down design eventually connects all these functions together, all the procedures together. So that's why it's very likely that these things here got changed and modified and will affect everybody. All right, and then you might see that, oh, it's not a really big deal, it's pretty clear. And this one here, just one definition, I changed 4 functions. I don't mind making that changes. But guys, here, I really want you to remember what I said today. When you are learning the principles here, most of the examples I gave you in the class are just like this, okay? You can write and code it very quickly within 5 minutes, and I can show you the idea. But that doesn't show what the reality looks like. In reality, when you have a system like this, it's not gonna be 40 lines of code, okay? I think you'll probably need 4,000 lines of code. And instead of 4 functions, you probably need 400 functions. At that time, if I tell you to change this variable, it's almost impossible because besides changing all this text, the types, you got to test everything. You just cannot imagine how many more things you have to change and how many more things you will probably break. All right. So that's why sometimes the software doesn't work. People just drop it and then just redo another one, because it's really literally you can't go back to change all the code. There's too many places, and then you fix all of this, and then it brings new problems. All right, so that's why a lot of these issues we told you in class with a simple example, you need to have, you need to think a little bit bigger, okay, to say, okay, what if I have 400 functions I need to change? That's not going to be this little changes like this. All right, so that's another issue about extensibility. Last one is also about security, okay? Because especially when if you're familiar with C, you only can have two different variables, local variable like this, or global variable. If you put your variable outside of a function, it's global, and then you can basically just touch this variable anywhere you want, such as here, when you display things, you can just use this buffer from the local global declaration. Most of those procedural languages have things like this. Even it's a different file, I can always include this file and I can use and access this variable. Okay, that's how the global variable works. I think in Python, maybe you also did some of the global variables. People like to do global variable because it's so easy. I can access it everywhere, but it provides such a big security risk because any programmers can go ahead to change it. All right, that's not what we want to see. All right. However, in C or some other language, there's no way you can prevent it because as long as you have used a global variable, you have to expose it. And you cannot really hide it. You cannot control the accessibility. And that is another problem related with procedural programming language. Again, think about it in a larger scale. If you're doing a banking system and you will have so much pressure on keeping the data like controlled and secure. Right. Yep. So that's the problem about the procedural programming language. Then let's move on, and then it's time to do the object-oriented programming languages, right? So that's why we have this motivation. We want to build a new type of programming language that give us this design approach that is closer to the real world, allow us to make changes easier, and also make the code more secure. All right, so everyone already knows what the OOP is, right? So the most important feature to have is a class. And the class had two things, data and also functions. All right, in different languages may call them different things, but a bunch of data definitions and also a lot of methods and functions inside the class. So you wrap them together. When we were learning C++ when I was in college, because we start with C. So when you learn C++, you realize, well, the C++ is only an extension that provide this new thing called a class that allows you to put the definitions and a method together. That was my initial impression about C++. However, the C++ is much more than that. It's more, again, not about the language features. It's about the design approach, the design idea. Okay, that's how this OOP has been changing people write the software. But the first and foremost thing is you need to follow that approach. Okay, so some of the good things about the OOP, as I mentioned, you can specify the specific attributes for the object you're trying to program, and then you make this function specific to the behavior. That's how you can reduce the gap between the programming world and the real world. Here is another interesting example. We'll look at this one more carefully in the future. We'll talk about some of the design patterns. And that's just a little funny image that people are talking about how the object-oriented programmers seeing the real things, real world. For example, I'll give you an example here. It's called the TV called entertainment provider singleton. So we'll learn this pattern called a singleton pattern. Now the singleton pattern means that in this whole program, for certain classes, you only want to have one single instance. You don't want to have a second one because of the security or management concerns, right? So if you make some classes that singleton class, then we call this as a singleton pattern. But because this TV is the only entertainment channel you have in these rooms, that's why the programmer can consider this as the entertainment provider singleton. All right. So this is the kind of image to show you some of these design patterns, with the real world examples. But also you can see that it's very easy to connect the object-oriented features and concept to the real world because that's how the OOP was designed for, to reduce the gap between the programming and the real world. Also, for OOP, you can now encapsulate data. Some of you didn't mention that, right? So in Java, you can make things like private, and suddenly that data becomes invisible for outside of the class. That's how you can control the security. Now at least you have a choice of making things public or private, right? So, but in terms of how do we choose private or public, when do we use private, when do we use public? So we're going to talk about that one shortly, okay? And also it supports better modularity because now everything has been encapsulated. It's one entity. So you can just make sure the things are not affecting each other too much. So you reduce all those connections, not like top-down design procedural. Every procedure is connected to another one. Now we try to keep all the entities separately. So eventually you just need to put them together and let them to do the minimum interaction as much as we can. That allows us to build different parts separately. For example, I don't know how many of you have seen this Boeing tour. Next time you go to Seattle, you should actually take a look at this tour. Very cool. You can actually see the assembly line where they make the 787, 777, 747. It's pretty much they're just putting things together. People are working in parallel. I think they said they can make a plane like every 3 days. Okay, so I think they talk about 737. They can make one plane in 3 days. Okay, it's pretty impressive. All right. Finally, they support reuse and extensibility. All right. So with all this concept, I don't want to bore you with all the slides. Okay, let's come back to this example one more time. All right. So text message example. Now it's time to switch to OOP. All right. So I actually opened the Eclipse. Okay. Not sure what you guys are using. Okay. I'm a use Eclipse most of the time. I know IntelliJ is more popular now, maybe, but it doesn't matter. So I'm going to create the same example. I'll call it messaging service in Java. All right. Okay, so I'm going to do this one in 2 different ways, very quick. All right, so we don't have a lot of time, but I want to finish the example. So I can still use a similar approach to code this messaging system in Java. So such as this, okay, I create a public static method called a get message from input. All right, so this one is going to return a message. All right, obviously you can do a scanner. This way in Java we can, come up with a better way to write this one since I'm still very familiar with Java, even though I'm not really using that too much this year. All right, so I can return the message. All right, so that's one method, right? So I got that input from keyboard, and I can just send the message. Here I'll just simulate, okay, message. All right, so same way, I need to have something to receive the message. I'll do this one to say that receive message. When you do the receive message, you're basically putting things to your buffer, right? So I'm going to create another one here, public static string message buffer. All right, so I can then receive this message from network. All right, and then once you got it, you can always go ahead to display the message. All right, so I finished. And then to use this one, it's really easy. So all I need to do is to say, I got a message and I want to get the message from input, and then I will just send the message. Oh, sorry, public static. All right, same case, I can use a while true loop. All right, and I'll just receive the message, and every time I receive it, I'll just do a display. Okay, just an example. Okay, again, not a very perfect code, but show you the example. All right, guys, I did a really quick to make this Java program, and now you see I'm using class. All right, I have a method, I have attributes. All right, now the question here is, are we following the object-oriented design? In other words, how much difference between this one and this one? Right? No difference. Very clear, no difference. Okay, so that's a very, very important message I want to show you guys. Even you are using Java, you're using Python, how many of you are writing code like this? Okay, this is exactly procedural programming language design. Okay, so design is not about the language, it's about how you, approach the design and how do you, build the component one after another. You will still need to face the same problem. Now, one time I have to change the message from string to something else. Okay, maybe also a file, for example. And then if that's the case, then you got to change this one into file, and that's going to basically break everything, right? If this is a file, then this one had to be a file, and then everything. This one had to be a file, this one had to be a file, and this one here is a file, and pretty much everything. All right. So yeah, so many changes. Okay, maybe 4 methods, but in reality, maybe 400 methods. You got to change all the signatures and also internal data. You might also want to think, what if I want to support both? Okay, so another way is I can write things like this, just very quick. Okay, so I can do another one. So you don't want to like just change that one. I can do another one. I can say get image message from input, and where I have a file here, right? That is also fine. And then you got 2 different things here. You got one for text, one for image. All right. So that's another way you can do it. You create 2 functions. However, when you have 2 functions, you also need to have 2 functions for this one. And then send image message. That's going to take a file. All right. Since now you have 2 sets of functions, you also need to duplicate this one. I'm not going to write it, but from here in the future, you will need to somehow choose which type you want to go. All right, so maybe you will need to have another thing here called, this one will be like, okay, send message parent, okay? And then you have to provide a type, okay? If the type is 1, then that means you want to do, the text message over. All right. Otherwise, maybe you will do another one. All right. So every time you're going to call this one and then you press the type, and that's how you can solve this problem one way. But that's still not object-oriented, because what if I add a third one? I add another one called video stream. And then you need to go here to change it, you need to add that one. Or later on, I realize, oh, the video actually, I don't need the image anymore. And I need to go ahead and delete all of this part. And then delete this method. All these changes back and forth. Okay. As I'm typing, you can start to feel that this is not really ideal way to code it. All right. The reason you don't feel it's right because there's changes. If we just keep the code there, just like somebody mentioned earlier, it's very organized, it looks nice. I totally agree. But what about the changes? Okay. So the really better way to code this little program, okay, is you have to separate some of this concept. because some of this thing you're thinking, like the change that we're making, mostly about the message types, because that's going to affect how you actually send and get input, how you display stuff. All right, but that's actually really is related with the specific message rather than specific to this messaging system. Messaging system, all they try to do is just try to send and receive, send and receive. But in terms of how you get the message, where the message come from, where the content come from, it's actually not part of the, it's not part of this messaging service role, right? So let's just code something really quick. I'm gonna create a new package. I'll call it optimized. All right, so we're running a little bit late. I'm gonna speed up a little bit. All right. So for some reason, today I had a very bad control on the class time. All right, so I will need to create a message, but since I know there may be different type of messages, all right, so what I will do is I'm gonna create, a interface first. I'll call it iMessage. And I need to think about, for every message, what are the things I need to do? Okay, one thing I need to do is to get message from input somehow. Another thing I need to do is how do I deal with display? Display message. All right, so every single message, you need to actually handle these two things very well. Okay, whether it come from a keyboard or file, you pick a file from a phone, or when you display that, do you want to show animation or you want to show pixels, all of this, you go ahead and deal with it, but it's not a part of the messaging system. So I define the function for this entity, class for this entity first, and I'm just going to start creating my types. I have my text message. All right, so this one is going to implement this message interface. The moment I do this one, I have to implement this too. Okay, but that's okay. I have my message as string. I'm going to deal with that with string. So here, then you can just say how you want to form a string, and then here is how you. Oh, sorry. How you want to print it. Right? So if I make something like this, now everything is about the message. So I'm going to try this very quick, guys. So I'm going to move this code here to this new package, okay? And then I will actually clean up the code. All right, so first of all, I don't need this one here. I will just come back to this normal like string approach. All right, so this one here. And then let's see what kind of changes we can do once we have this new entity. So I introduce this iMessage. And now when I code this one, all right, so this one become an iMessage because it really doesn't matter what kind of message you're doing. All right, so, oh, actually, no, sorry, I take it back. So this one shouldn't, the getting input shouldn't actually come from the message. So we just need to pass a message directly to here. So this one will have an iMessage right here. And then this one is going to deal with, get the message input and then somehow send it out, right? So this one really does not belong to here. And then the sending the message, same thing. All we need to do is give me this message. Oh, sorry, this I don't need it. All right. Receive the message, same thing. All I need to do is create a buffer to just receive the message. It really doesn't matter what the message type is. And once you receive it, and then you can just call display. All right, and then so you don't have to deal with the display right here. And then when you start to use this system, and the things become much better. So I have a iMessage. Okay, I got a text message. And I can create this one here. And then I will just use that one just to send it. I'll call send message. This one here. All right. And then this one is going to work as normal. All right. So why I think this one is better? Right now, if I only have this code, I can't really claim this one is better than this one. Okay, only when I talk about the changes. And same scenario, now I need to add one more type of message, image. Now things become easy. I go up here, create a new class, I call it image message. All right, so this one is also a type of iMessage. All right. I know this one need a file. That's okay, we'll do a file. It doesn't matter. And internally, we're just dealing the file. However, no matter how many types you're adding, this part of the code remains exactly the same. You're not changing anything. All you need to change is on the user side, oh, now I actually have a new type of message. Right? And then could you send it? These functions always remain the same. Also, another thing, I guess, I don't know if you saw it, when you're adding something new, the only thing you're doing is adding this new type. You're not touching and changing anything else. Okay, you're only doing the addition. You're not doing the update or modification. That's some of the principle we'll tell you later on. The best design to deal with the changes is only addition, not modification. Because when you deal with a modification, that means you have to jump into the code and then do these things. And then when you change this one, it's going to affect others. Try to avoid modifications. If your thing is only addition, that means if one point I don't need this anymore, I can just go ahead and delete it. All right. I don't need the text messages to old fashioned way. I'm going to delete this one. The moment I delete it, it's not going to affect anything else. Okay, except this one. This is just how users using this. All right, but then this part of the code remains the same. All right. So this is called object-oriented design and programming. All right. A very important feature we're using here is something called inheritance. The way to implement inheritance is we use the interface and then we use different types. And then the service actually focuses on the parent type without worrying too much about the specific behavior, because they know that every single message follows the same kind of style. And that's how we can avoid all these extra changes. All right. So anyway, guys, as you can see, when you are doing the OOP, the program and then the way you think about this one become different. This one, you actually start to think about what the message looks like, what are the features you need to have for this message, and then you build the classes. Where the other one, you think about that as an assembly line type of approach. Okay, it takes some time. It takes some time to get you to this new style. Okay, Jimmy, this is not the generic type. Okay, the polymorphism is so much more powerful than generic type. Generic type is just a little feature in Java or C++ that helps you to deal with the types. But it's not just about the types. There are so many more changes that's not just cannot be handled by the type only. All right, but generic type is a good thing, but that's not the OOP design. All right. So anyway, guys, to kind of have a quick summary here. All right. So keep in mind, you should start to kind of review your code you're doing every day. All right. Did you actually use, when you're writing Java or Python, do you use a class? Do you use a parent class, interface, abstract class? Do you have polymorphism? Do you have an override? Okay. Do you hiding a lot of information? For example, private. All right. If you're not using any of those, you're pretty much not using object-oriented programming. Okay, you're just doing the old-fashioned procedural programming language, which is okay, but it's not okay when you deal with larger and more complicated systems. And you will face more challenges. All right, so I'm going to stop here, guys. I will actually upload the video and slides, and then I'll send you the link. So next time we'll talk more about the design, specifically some of the Java features that you probably don't use very often. All right. So any other questions, let me know. I should be still available